Hello everyone. Today we are going to discuss an important interview problem that uses a very simple but smart trick. Here is the problem. A wire connects n bulbs. Each bulb has its own switch. However, due to faulty wiring, when you press a switch, it not only changes the current bulb but also changes the state of all bulbs to the right. We are given the initial state of all bulbs in an array. Our goal is to find the minimum number of switches required to turn on all the bulbs. Also, a switch can be pressed multiple times. In the array, 0 represents a bulb that is off, 1 represents a bulb that is on. Let's understand this with an example. Imagine a row of bulbs, some are on and some are off. If we press the first switch, the first bulb turns on, but all bulbs to the right changes their states. On bulbs become off bulbs become on. Similarly, when we press the second switch, all bulbs to the right changes again. Our goal is to make all bulbs on using the minimum number of switches. For this problem, we use a famous technique called the greedy algorithm. A greedy algorithm means making the best possible choice at each step without reconsidering previous decisions. In this problem, we fix bulbs as we see them and move forward. We don't go back. Consider this array. The first element is 0, so we must press the switch. Now this bulb becomes on and all bulbs to the right flip their state. We keep track of how many switches we have pressed. Now the second element effectively becomes 0, so we pressed again. That's the second switch. The third bulb is already on, so we skipped it. Let's move to fourth. We pressed the fourth bulb switch. All the right elements got switched. Then we continue this process. Every time we see an off bulb, we press the switch and increment the count. Fifth switch. And sixth switch. Finally, all bulbs become on. So the minimum number of switches required is 6. But here is the important question. Are we really going to flip all the bulbs to the right every time? That would take extra time and space, which is not efficient. So let's observe something interesting. If we toggle a bulb once, its value changes. If we toggle it twice, it returns to the original state. For 3 times, it changes again. For 4 times, back to original. From this, we can conclude that for odd number of switches, the value will change, and for even number of switches, the value will not change. This is the key insight. Instead of actually flipping bulbs, we just track how many switches we have pressed so far. Using this count, we can determine the current effective value of any bulb. Here is the steps to solve this problem. Maintain a variable to track the number of switches. Iterate through the array from left to right. For each iteration, check the current value of the element using switches. If the switches is even, the value is same. If the switches is odd, the value got changed. If the current value is 0, increment the switches. Otherwise, skip. Finally, return the switches. The time complexity of this is big O of n. We only traverse the array once. Using a greedy approach and a simple observation, we avoided nested loops and extra space. Let's solve this problem using programming. As we discussed, we are going to have a variable switches. I'm initializing it with 0. And then we are going to iterate the array from left to right. And we are going to find the current value based on the switches. If the switches is even, the value will not change. Otherwise, the value got changed. And based on the current value, we are switching. Finally, I'm printing the switches. Let's see the output. And it is 6. That's it. I also provide iOS training, resume reviews, and mock interviews for those who want to grow in their careers or switch into iOS development. You can also contact me for freelancing support. If you are interested in any of these or need guidance, feel free to reach out to me at amptechtraining@gmail.com. I'm happy to help. If you found this video useful, please like, share, and subscribe for more such content. Thanks for watching.